So now let's talk about what algebra tiles look like with this combining like terms and the distributive property. So here I tell you guys that these long ones are the x's, the blue is positive, the red's negative, and the same thing with these small squares. They each represent 1. So what we can do is when we're looking at these like terms, we can use these algebra tiles to help us show what they represent and show what we have. So, don't look at that down there. Don't see that number. Don't see it. There it is. It's gone. So here we see the expression 4x minus 3 plus 2x plus 1 minus x. And then they wrote those out showing with algebra tiles. So 4 x's, that means I have 4 of those x blocks. Minus 3, that means I have 3 of those minus 1 blocks. 2x, 2 of the blue ones because it's positive, plus 1 was 1 of those pluses, and then minus x. So that's one of my negative x blocks. I can take each of these chunks and I rearrange them together to make the like terms. So like we talked earlier in class, the x's mean that they are like terms because they have that same variable. So if I take all those long bars, all those x's, and I put them together, I see I have a 0 pair because I have a negative and a positive. They cancel each other out. So what's left is 1, 2, 3, 4, 5 positive x's. So I would write that as 5x. And then over here, again, I rearrange the ones, the numbers without any variables, those 3 negatives, that 1 positive. A positive and a negative makes a 0 pair. So I'm left with negative 2. And then I combine those two things together to make the expression to simplify it. I always want to write the variable part first. So I would write 5x, and then because that's a negative, it's going to be a minus in my expression. So that'd be 5x minus 2. Let's do the same type of thing over here. For our expression, first we see we have 1, 2, 3 negative x's. So that would be negative 3x. Then 2 positives. So that's plus 2. 1 negative x. So it's just going to be negative x. Remember, there's that imaginary 1. 4 negatives. So minus 4. And then 3 positives. So plus 3. If I simplify that expression, I put all my x's together. They're all negative. I see I have 1, 2, 3, 4 negative x's. So that'd be negative 4x. And then for my other ones, I see a negative and a positive make a 0 pair. A negative and a positive make a 0 pair. A negative and a positive make a 0 pair. A negative and a positive make a 0 pair. So I'm left with 1 positive or plus 1. So that's combining like terms with algebra tiles. I can also do the same thing with the distributive property. If I have, for example, 2 times 3x minus 1, that translates to 2 groups of 3x minus 1. So here's my 2 groups represented by the circles, and each of those groups has 3 x's and 1 negative. 3 x's and 1 negative. So altogether, how many x's do I have total? 6 x's. And how many singles, how many constants? Negative 2. And if we did it the normal way that we've been doing it in class, 2 times 3x gives me 6x. 2 times a negative 1 is going to give me a negative 2. Same thing, 6x minus 2. So now they want us to do the same type of problem. They want us to draw it using the expression 3 times the quantity 2x minus or plus 3. So here I see I have 3 groups. So I need to draw 3 circles. And then inside, I have 2x plus 3. So 2 x's, those are positives. Those are going to be my long blues. I need 2 x's in each of my groups. And then I have plus 3 in each group. Those are positives. Those are going to be the small squares. So I need to draw 3 of those in each group. And then I combine it to see what I've all got together. I have 1, 2, 3, 4, 5, 6 positive x's. And then I have 1, 2, 3, 4, 5, 6, 7, 8, 9 positives. So it's going to be plus 9 because they're all positive. So all together, our expression simplifies to 6x plus 9. And again, if we do it the other way, 3 times 2x gives me 6x. 3 times 3 gives me 9. Yay, us! Oh boy. Oh boy, where'd it go? How do I shut it down? There we go.